in various ways or in various examples, applications, you can see that there is interconversion of these energies. So in thermodynamics, we study about this interconversion of energies and the different forms of energies as well. Using different properties, I am able to specify or describe this particular system, right? So that is called as the state of the system. So if we are saying a process is isothermal, that means the temperature is constant there. Even though the other factors changes, the temperature will be a constant. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with a new chapter, right, that is thermodynamics. So today we are beginning with the chapter thermodynamics. So in this session, we will be discussing about thermodynamic terms. Yes, we will be studying about what is thermodynamics and introduction to it, and then we will be studying the different thermodynamic terms, right? And then different types of system, state and function and path functions, right? Extensive and intensive properties, and then the different types of thermodynamic processes also we will discuss in this session, right? So yes, to begin with, what is thermodynamics, right? This is a new branch for you. What is thermodynamics? Yes, it is the branch of science which deals with the study of different forms of energy and their interconversion, right? So as the name suggests, thermodynamics. Okay, so it's of two words, right? Thermo and dynamics. So thermo means heat and dynamics means change. Okay, so thermodynamics is about the change in energy from one form to another form. Yes, it is about the interconversion of different energies, and we study also about the different forms of energy. Right, so thermo and dynamics, the interconversion of these energies. So let's take an example of batteries. Yes, we know that in battery what is present? Chemicals are present, right? So it consists of chemical energy, right? So why we are using batteries? So in the phones, so in the watches we use, in the calculators, right? In all these batteries are there. So what does these batteries do? They convert this chemical energy, that is the chemicals that is stored inside them. They convert this chemical energy into electrical energy, right? So what is happening? There is an interconversion of energy that is taking place, right? From chemical energy, it is converting into electrical energy, right? And in the same way, let us take methane, right? Methane undergoes combustion. It releases a lot of energy, right? It releases a lot of heat, right? So in the case of combustion of methane, what is happening? Chemical energy is getting converted into heat energy, right? So in various ways or in various examples, applications, you can see that there is interconversion of these energies. So in thermodynamics, we study about this interconversion of energies and the different forms of energies as well, right? And once we are studying about thermodynamics, we get the answers for the two questions as well, right? Will a reaction occur or not? Right, so we know that chemistry is about chemical reactions and the reactants and products and everything, right? So we will get to know about whether a reaction will take place or not. Yes, you will get the answer for that from thermodynamics, right? And one more thing, to what extent the reaction will take place. Yes, so first, whether the reaction will take place or not, we will understand it, right? And to what extent, right? To how much extent the reaction will take place, right? How much of the reactants will combine and form products, right? How much amount of product we will obtain. All those we will get to study under thermodynamics, right? So yes, we are studying a new thing, so we need to understand about the different terms of thermodynamics as well, right? So the first one is system. Right. So what is system? It refers to the portion of the universe which is under observation. Right. Which is under observation. So if I am going to study about this pen. Right. So this pen is my system. Right. So it is the portion of the universe. So in the universe, I am considering this pen as my system. Okay. So this is the portion of the universe under which I am going to study or which I am going to observe. Right. So that is the system. Right. Now what is surroundings? Everything else in the universe except the system is called as surroundings. Right. So except this pen, whatever is in the universe, that is called as surroundings. Right. So let's take this diagram itself. There is a solution which is taken inside a conical flask. Right. So this conical flask along with the solution, that is my system. I am observing this. Right. So I am going to study about the solution. So this conical flask with the solution is my system. Right. Now, what is the surroundings apart from this conical flask? See, it is present inside a box. We have kept it inside a box. Right. So, apart from this conical flask, the whole of this box will be my surroundings. Right. So, you can see here, it is shaded blue. That is the surroundings apart from the conical flask. Okay. Right. So, these two together, that is the system plus the surroundings will be what? System plus the surroundings will be the universe. Right. Okay. So system is the portion which is under observation. Whatever apart from the system, whatever is present, that is called as the surroundings. So what does that mean? System plus surroundings will be equal to the universe. Right. Now the next term is boundary. Now that is the wall that separates the system from the surrounding. Okay. So the conical flask is my system. Okay, so the walls of this conical flask will separate it from the surroundings, right? So that wall is called as boundary. Okay, and this boundary can be real or imaginary. Okay, so in this case of pen, yes, we know that this is the system. So whatever it is present around, that is the surroundings, right? So a boundary that separates between the system and the surrounding, it is called as a boundary. Right, okay, and it can be real or imaginary. Okay, so that is about system, surroundings and boundary. Right, now moving on to different types of system. Right, so what is system? It is that portion of the universe which is under observation. Right, so there are different types of system as well. Open system, closed system and isolated system. Right, so first one is open system. System in which there is exchange of energy and matter with the surroundings. Right, there is exchange of energy as well as matter with the surroundings. Right, so let's take coffee in a cup and I am keeping it outside. I am not closing it with the lid. I have coffee in a cup and I have kept it on the table. Okay, so what happens after a while? You can see, yes, the vapors getting converted, right? Yes, from the liquid it is getting into vapor state. So there is a change in matter there, right? Matter exchange is taking place. Yes, as well as what is happening to the heat. We had kept hot coffee there. So after a while it becomes cold, right? So there is a change in heat as well as matter there. There is an exchange of matter as well as heat. Right. So same way in this diagram you can see it is an open test tube which is kept. So from this easily the matter and heat can be exchanged with the surroundings. Right. So this is my system and from here it can be exchanged with the surroundings. Right. So that is open system. Now coming on to the next one, that is closed system. A system in which there is no exchange of matter. No exchange of matter, but there can be exchange of heat. Okay, so in open system there is exchange of matter as well as heat. In case of closed system, right, the same hot coffee we are taking, now we are closing it with the lid. Okay, so now what happens to the vapors? It gets blocked in the lid, right? It doesn't come out of the coffee cup because it is covered with the lid now, right? So is there an exchange of matter happening? No, right? The vapors are not able to escape from the cup, right? But still the hot coffee after a while it becomes cold, right? Why? Because there is a exchange of heat taking place. So in the case of closed system there is no exchange of matter, but there can be exchange of energy. Right. Okay. Now isolated system. Now what about isolated system? In which there is no exchange of matter and no exchange of energy as well. Yes, let's take the thermos flask. Right, the flask where you keep hot water, right? Yes, what happens? Even after a while you take it and drink it, still it will be hot, right? There is no change of there is no exchange of matter as well as there is no exchange of energy, right? Yes, so if we are keeping under it in an isolated condition, that is like a thermos flask, there will be no exchange in matter as well as no exchange in energy. So that is about the different types of system: open, closed and isolated system. Right. Now coming on to state functions and path functions. So before understanding state functions and path functions, you need to be knowing what is the state of a system. Okay, so state of a system. If I am considering this pen itself, I have to define the state of the system. That means like under what pressure it is there, what is the temperature, what is the volume, what is the mass. Using different properties, I am able to specify or describe this particular system, right? So that is called as the state of the system, right? We express any system, let us say, we are expressing it using different properties. We are talking about the pressure, the temperature, the volume, the density. Yes, so that is the state of the system. Now there are two types of functions, that is state function or state variables and path functions or path variables. Now what is state function? State functions only depends on the initial and final state of the system and not on the path followed. It only depends upon the initial and final state and does not depend upon the path followed. Okay, so one example is pressure, another example volume, another example temperature, let's take. So initially the temperature, pressure and volume was P1, V1, T1. Let us consider, right? So now what we are doing, we are changing the pressure, volume and temperature. Yes, we are observing the system, right? So what changes it is happening? Let's say it is getting converted into P2, V2 and T2. The pressure, it becomes from P1 to P2. Volume changes from V1 to V2. Temperature changes from T1 to T2. Okay, so what is happening here? The initial and final pressure or initial and final volume or initial and final temperature is important to us. Yes, the path through which it has come from P1 to P2, it is not important for us, right? Yes, initially it was P1, finally what it is P2. Yes, so that change is only required for us, that is initial and final. What kind of pressure you have applied to there, it is not necessary to understand. Yes, so such functions are called as state functions, which only requires to be known about the initial and final state and not the path followed. Now what is path function? As the name suggests, it depends on the path followed. Yes, not just the initial and final positions, that is initial and final states. The path followed is also important, and the two path functions are work and heat, right? So in the case of work and heat, not just the initial and final state, but also the path followed. That means what work is done, whether it is mechanical work, chemical work, right? All those is important. What amount, what heat is evolved, right? Or what heat is required there, that is important, right? So that is about path functions. I hope it is clear. Now moving on to the next one, that is extensive and intensive properties, right? So what are extensive and intensive properties? Let's say first one, extensive properties are properties which depends only on the amount of matter present in it. Yes, so such properties, the amount of matter is important. Right, extensive properties are properties in which the amount of matter is important. So let's take the example of length, right? Breadth, height, internal energy, enthalpy, entropy, Gibbs energy, heat capacity, all this comes under extensive properties. Let's take the case of volume itself. Volume is also an extensive property, right? So if I'm taking 10 gram of a substance and I'm taking 100 gram of a substance, right? So of course the volume will be more, right? For 100 gram of substance, the volume will be more. For 10 gram, the volume will be less. So the volume will keep changing depending upon the mass present, right? Yes. So that is extensive properties. The mass is important there, right? So such properties are called as extensive properties. Now coming on to the next one, that is intensive properties. So intensive, this in is there, you can remember it that way, it is independent of the mass. Intensive properties are properties which are independent of the amount of matter present. So here the mass or the matter, amount of matter present is not of importance. Okay, one such example is temperature, pressure, density, all these are examples of intensive properties. Let's take the case of temperature. Okay, we know the boiling point of water is 100 degrees Celsius. If I am taking 20 ml of water or 100 ml of water, in both cases it is still water, right? See, the mass or the volume change is not having an effect there. Even if I am taking 20 ml or 100 ml, in both the cases, the boiling point of water will be always 100 degrees Celsius, right? So, such properties are called as intensive properties. Okay, so that is the difference between extensive and intensive properties. So now let's discuss about the different thermodynamic processes, right? So under different conditions, what are the different thermodynamic processes you can define? Let's see. Okay, so this is of importance for your whole chapter, right? So the thermodynamic terms we have discussed and the different thermodynamic processes are important for your thermodynamics chapter, right? So let's begin with the first one, isothermal process. So what does iso means? Iso means same or constant, right? So isothermal, thermal relates to what? Temperature, right? So isothermal process is what it will be? Those processes which takes place under constant temperature, right? Yes, when the process is carried out at constant temperature, such processes are called isothermal. So if we are saying a process is isothermal, that means the temperature is constant there. Even though the other factors changes, the temperature will be a constant, right? Now, isobaric process, right? See, what is the unit of pressure? It is bar, right? One of the unit, it is bar. So, how you can remember isobaric process? What will be constant there? Pressure will be constant there, right? So, when the process is carried out at constant pressure, such processes are called as isobaric process. Now, what is isochoric process? Isochoric process, the volume will be constant. When the process is carried out under constant volume, it is called as isochoric process. Okay, so these three are clear. Isothermal, constant temperature. Isobaric, constant pressure. Isochoric, constant volume. Right. Now moving on to the fourth one, that is adiabatic process. Yes, this might be a new term, adiabatic process. So the process in which there is no transfer of heat between the system and surroundings. Such processes are called as adiabatic process. Right. So in this case, delta Q will be equal to 0. That is, the change in energy will be 0. Yes, there is no transfer of heat. Yes, so delta Q will be 0. Okay, that means from the system, neither it is going to the surroundings or from the surroundings, the heat is coming to the system. Okay, so there is no change in heat there. Okay, such processes are called as adiabatic processes. Okay, so in the isothermal, what it is? Delta T will be 0, right? There is no change in temperature. That is constant temperature. In case of isobaric, delta P will be 0. In case of isochoric processes, delta V will be 0. In case of adiabatic process, there is no change in heat. That means delta Q will be 0. Now coming on to cyclic processes. From the name itself, you can say cyclic processes. The processes take place and finally it comes to the initial state itself, right? So the processes take place in a cyclic manner. The system undergoes a series of changes and returns to its initial state, right? It undergoes chemical reactions. So many changes happens to it. Finally, but it will reach its initial state itself. Okay. Now coming on to reversible process. You know reversible and irreversible process, right? So reversible process, a change is brought in such a way that the process could be reversed at any moment by an infinitesimal change. Okay. So at any moment you can reverse the reaction. So such processes are called as reversible processes. Now irreversible process, which can't be reversed, right? So the process only takes place in one direction. Okay, it can only form the products, or we can say it can only happen in one direction. From there you can't bring it back, right? So once the products are formed, you can't bring back the reactants. Okay, so such processes are called irreversible processes. So I hope all the different types of thermodynamic processes is clear for you, right? Isothermal, isobaric, isochoric, adiabatic, cyclic, reversible and irreversible, right? So in the next session we will be discussing about internal energy, right? Internal energy and how you can bring a change in internal energy by doing work and by the transfer of heat. Okay, by work and heat, how you can change the internal energy, and we'll be discussing the first law of thermodynamics and then work done in isothermal reversible process. Okay, so the thermodynamics is governed by various thermodynamic laws, right? So in next session we will be studying the first law of thermodynamics, right? We have second law as well as zeroth law as well. Okay, so we'll be studying the first law of thermodynamics in the next session. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.